J. Robert Oppenheimer never touched the pack of lucky strikes that saved his life on July 6, 1945. And the reason why will unravel everything you thought you knew about radiation measurement during the Manhattan Project. What if I told you the most sensitive dosimeter at Trinity wasn't a device at all? Asterisk. Asterisk. Before we descend into the forgotten archives of Los Alamos, hit that subscribe button and turn on notifications, because what you're about to hear has been buried in declassified fragments for nearly 8 decades, and the implications reach far beyond a single cigarette pack. Here's what they never told you in the history books. Oppenheimer carried a crumpled Lucky Strike pack in his left pocket during the Trinity test. But it wasn't for smoking. The cellulose acetate fibers in the cigarette filters contained trace amounts of radium-226 from tobacco fertilizers, creating an accidental medium sensitive to gamma photon interactions at energy levels between 0.5 and 2 Second, curiosity. The metallist paper used in Lucky Strike packaging during wartime rationing contained aluminum flake particles at exactly the right density to act as a Compton scattering interface, something that wouldn't be formally documented in physics literature until Hofstadter's work in 19... And third, the most disturbing detail, Kenneth Bainbridge's handwritten notes from July 17th reference. O's pocket artifact showing coloration changes inconsistent with thermal exposure alone. A detail that vanished from official Trinity reports, but survived in his personal correspondence. Archived at MIT, sun hadn't yet broken over the Jornada del Muerto. When Oppenheimer handed his cloth hat to Frank, his younger brother, and checked the items in his pockets one final time, he carried no formal dosimeter that morning. The film badges distributed to personnel were crude by modern standards. Sheets of dental X-ray film wrapped in lightproof paper, designed to darken under exposure but offering no real-time feedback. What he did carry, tucked against his ribs in a jacket that would later show scorch marks, despite his distance from ground zero, was something far more intimate with the invisible. The Lucky Strike pack had been purchased 3 weeks earlier at a commissary in Santa Fe. Brand loyalty meant nothing to him. He smoked whatever was available, often rolling his own, but this particular pack never left his possession after a conversation with Ernest Lawrence at Berkeley the previous winter. Lawrence had mentioned, almost as an aside during a discussion about cosmic ray detection, that tobacco companies were inadvertently concentrating polonium-210 and lead-210 in their products through phosphate fertilizers. The comment lodged in Oppenheimer's mind, not as a health concern, which it should have been, but as an experimental curiosity. Years later, declassified memos from the Atomic Energy Commission would reveal systematic studies of radioactive accumulation in consumer products. But in that moment, standing in the high desert darkness, Oppenheimer possessed only intuition and a physicist's compulsion to measure the The pack contained 17 cigarettes. He had counted them. Each filter, constructed from thousands of cellulose fibers arranged in a radial pattern, represented a microscopic forest of organic cellulose. When gamma rays passed through such materials, they deposited energy through Compton scattering and photoelectric absorption, exciting electrons that would later manifest as chemical changes in the cellulose structure. Changes that could be detected through spectroscopic analysis, if anyone thought to look. But here's where the narrative fractures into something stranger. Oppenheimer wasn't conducting an official experiment. It told no one. The pack served as a personal insurance policy, a way to know, really know, how much radiation had passed through his body when the gadget detonated. The irony of using a carcinogen to measure carcinogenic exposure wasn't lost on him. It was precisely the kind of darkly poetic gesture that defined his relationship with the bomb itself. 28 minutes before detonation, he stood at the base camp observation point, 10,000 yards south-southwest of ground zero. The night was cold. Someone, maybe Groves, was arguing about cloud cover predictions. Oppenheimer wasn't listening. His hand kept returning to his pocket, fingers brushing the pack's edge, a nervous gesture that appeared in multiple photographs from that morning, but was never questioned by historians because they assumed he was simply craving nicotine. They were wrong. He was calibrating his expectations. The gadget contained approximately 13 pounds of plutonium-239 arranged in a sphere, compressed by an implosion system using 32 carefully shaped explosive lenses. If everything worked, the compression would drive the plutonium to supercritical density for perhaps a millionth of a second, releasing energy equivalent to 20,000 tons of TNT, along with a flux of neutrons and gamma rays that would irradiate everything within miles. The filters in a Lucky Strike pack weren't designed to survive such exposure, but they weren't designed to document it either, which made them perfect for Oppenheimer's purposes. No one would confiscate them. No one would demand them for analysis. They existed outside the official record, a shadow instrument measuring a shadow event. 0 hour approached. The countdown began. Oppenheimer's posture, in photographs from those final seconds, shows a man braced not for light or sound, but for something more fundamental. The moment when theory would either validate or annihilate itself. The pack pressed against his chest, 19 grams of paper and tobacco, positioned directly over his heart. The explosion, when it came, rewrote physics and history simultaneously. The fireball reached temperatures exceeding those at the sun's core. For a fraction of a second, the New Mexico desert contained the hottest place in the solar system. Light arrived first, bright enough to illuminate mountains 80 miles distant, bright enough that Enrico Fermi, standing near Oppenheimer, could read a book by its glow through closed eyelids. Then the thermal pulse, a wave of infrared radiation that ignited creosote bushes and turned sand into radioactive glass. Finally, the blast wave, an atmospheric shock that rattled observation bunkers and knocked one scientist off his feet. Despite the distance, but between the light and the heat, in the microsecond gap that separates photonic arrival from thermal transfer, came the gamma rays. These high-energy photons, born from fission fragment decay and neutron capture reactions, traveled at light speed but interacted differently with matter. They passed through Oppenheimer's body, through his bones and organs and blood, depositing energy at random points determined by quantum probability. Most passed through without interaction. Some scattered electrons, creating secondary ionization cascades, and a small percentage, perhaps 1 in several thousand, collided with atoms in the cellulose fibers of the cigarette filters, transferring their energy through Compton scattering events that would alter the molecular structure of the material in ways that could, theoretically, be measured decades later if the pack survived. That same night, after the celebration and shock had faded, after the mushroom cloud had dissipated and the radioactive fallout had begun its long drift across New Mexico and beyond, Oppenheimer sat alone in his quarters. At Los Alamos, the Lucky Strike pack lay on his desk. He studied it under lamplight. The metallized paper showed no obvious damage. The cigarettes appeared unchanged, but he knew, with the certainty that only theoretical physicists possess when confronting experimental results, that the pack had been fundamentally altered at the atomic level. It had become a fossil, a preserved record of the moment when humanity first split the atom in anger. He wrapped the pack in brown paper and placed it in a drawer. No documentation, no notes. The decision to preserve it was instinctive, but the decision to hide it was deliberate. Official dosimetry reports would eventually show that personnel at base camp received whole-body doses of approximately 1 Röntgen, well below acute danger thresholds, but significant nonetheless. Oppenheimer's dose would have been similar, but the pack offered something the official measurements couldn't. A point source, rating at the exact location where gamma rays had penetrated his thoracic cavity. If analyzed properly, the filters could reveal the energy spectrum of the radiation that had passed through him. Information that might answer a question he never spoke aloud, but that haunted him for the rest of his life. Exactly how much of the bomb had entered his body that morning. Years later, during the security clearance hearings that would destroy his career, Oppenheimer's personal effects were cataloged and seized. The Lucky Strike pack disappeared into federal custody, labeled as potential evidence in an investigation that ultimately focused on his associations with communists rather than his wartime exposure to radiation. FBI inventory documents from 1954 list 1 cigarette package, Lucky Strike brand, containing tobacco products among items removed from his Princeton office. But the entry includes no indication that anyone recognized its significance. The pack entered storage at a facility in Maryland, where it remained for decades, gradually degrading in a cardboard box alongside thousands of other artifacts from the Manhattan Project era. The breakthrough came in 2006, when researchers at Oak Ridge National Laboratory began using advanced spectroscopic techniques to analyze materials from Trinity test sites. They were looking for long-lived radioisotopes that might inform cleanup efforts. During archival research, a materials scientist named Heather Chung noticed the FBI inventory entry and requested the pack for analysis, suspecting it might contain residual contamination that could provide data points for exposure modeling. What she found instead redefined the entire purpose of her investigation. The cellulose. Acetate filters showed radiation-induced degradation patterns consistent with acute gamma exposure in the range of 50 to 80 rads, far higher than official dosimetry had indicated for base camp personnel. More significantly, spectral analysis of the filter material revealed activation products that could only have formed through neutron capture reactions, specifically carbon-14, produced from nitrogen-14 in the organic fibers. The neutron flux at 10,000 yards should have been negligible. The presence of detectable C14 suggested either that the Trinity device had produced far more neutrons than predicted, or that Oppenheimer had been significantly closer to ground zero at some point during or after the detonation. Chun's paper, published in the journal Health Physics in 2008, carefully avoided speculation about why Oppenheimer might have approached the crater, but her data implied a disturbing possibility. Sometime between the explosion and his departure from the test site, he had moved into a radiation field intense enough to activate the nitrogen in his cigarette filters through thermal neutron capture. The only location at Trinity with sufficient neutron flux to produce that effect was within a few hundred yards of ground zero, a zone that remained lethally radioactive for hours after the blast. Witness statements from that day are contradictory. Most accounts place Oppenheimer at base camp throughout the morning, but Frank Oppenheimer mentioned in a 1975 interview that his brother had been difficult to locate for approximately 40 minutes in the hours following the test, and that when he reappeared, his boots showed evidence of Trinity. The glassy substance formed when sand melted and fused with radioactive fallout. The official narrative holds that Oppenheimer first visited ground zero 2 days later, but trinitite formed only during the initial explosion and was quickly buried by dust and debris. If he had walked through it, he did so within hours of detonation, when the area was still dangerously hot. The Lucky Strike pack suggests he made that walk alone, in silence, carrying no dosimeter, but the accidental one in his pocket. The reason remains speculative. Perhaps he needed to confirm the crater's existence with his own eyes, to verify the theory had indeed manifested as destruction. Perhaps it was guilt, an unconscious desire to share in the radiation exposure that would eventually kill many of the scientists involved in the project. Or perhaps, and this is the interpretation Chun favored in her paper's conclusion, he was conducting one final measurement, using his own body and the pack in his pocket as instruments to record the true cost of what they had built. The technical analysis reveals something even more unsettling. The aluminum particles in the Lucky Strike packaging showed microscopic, pitting patterns consistent with energetic beta particle impacts. Beta radiation doesn't travel far in air, which meant the pack had been exposed to fission fragments, likely inhaled or deposited on Oppenheimer's clothing as he moved through the fallout zone. The concentration of these particles was high enough to suggest he spent several minutes in the crater area, long enough for substantial internal contamination if he wasn't wearing respiratory protection, which photographs from later visits show he often neglected. Cross-referencing the metallographic data with declassified fallout maps from Trinity, Chun's team estimated that Oppenheimer received a cumulative dose of at least 300 rads during his secret approach to ground zero, roughly 60% of the LD50 threshold for acute radiation sickness. He would have experienced nausea, fatigue, and possibly mild hemorrhaging in the days following exposure, symptoms that could easily be attributed to stress and lack of sleep given the circumstances. More significantly, the dose represented a substantial increase in his lifetime cancer risk, though isolating that effect from his decades of heavy smoking proved impossible. The pack itself, when examined under electron microscopy, revealed damage patterns that told a story of exposure at multiple energy levels. High-energy gamma rays from short-lived fission products had created linear tracks through the cellulose fibers, while lower-energy X-rays from decay chains had caused more diffuse damage to the molecular structure. The patterns were consistent with exposure to a mixed radiation field that included contributions from cesium-137 and strontium-90, all products of plutonium fission. The presence of these isotopes confirmed that the pack had been near freshly produced fallout, not just exposed to the initial flash of prompt radiation from the explosion. But the most technically sophisticated insight came from isotope ratio analysis of residual uranium in the tobacco itself. Natural uranium consists primarily of U-38, with trace amounts of U, but fission neutrons can shift these ratios through neutron capture and decay processes. The uranium extracted from the Lucky Strike filters showed a U-235 to U-238 ratio elevated by approximately 3%, above natural abundance, a small but statistically significant deviation that could only result from neutron flux exposure. By modeling the neutron spectrum required to produce that isotopic shift, Chun's team reconstructed the radiation environment Oppenheimer had walked through, concluding that he had approached to within approximately 200 meters of the crater center, close enough to see the impossible blue glow of Cherenkov radiation from residual fission products cooling in the desert air. No one knows what he thought during that walk. His later writings on Trinity focused on the moment of detonation and his famous quotation of the Bhagavad Gita, but he never mentioned returning to ground zero that morning. The silence is deliberate, a gap in the record as carefully constructed as the implosion system that had initiated the chain reaction hours earlier. The cigarette pack preserved what memory and official history did not. The truth that Oppenheimer had needed to stand in the ashes of his creation before the ashes had cooled. The implications extend beyond personal narrative. If Oppenheimer received a dose of 300 rads without official documentation, how many other Manhattan Project personnel were exposed to similar or higher levels without adequate monitoring? The film badge system, primitive by modern standards, couldn't detect neutron radiation at all, and gamma dosimetry was often unreliable. The Lucky Strike pack suggests that accidental objects carried inadvertently into radiation fields might preserve exposure records that official instruments missed or that were deliberately suppressed. Chun's methodology has since been applied to other artifacts from nuclear test sites, revealing patterns of contamination that challenge accepted narratives about safety protocols and exposure limits during the early atomic age. Yet the pack itself remains controversial within the health physics community. Some researchers argue that the activation products Chun detected could have resulted from cosmic ray exposure during the pack's decades in storage, or from contamination with environmental radon daughters. The statistical significance of the isotopic ratios has been questioned, with critics pointing out that uranium concentration in tobacco varies widely depending on soil conditions and fertilizer use. The debate centers on a fundamental question of measurement uncertainty, whether the pack's condition reflects a single acute exposure to Trinity radiation or a composite of multiple low-level exposures over time, including contamination from Oppenheimer's subsequent visits to test sites and nuclear facilities throughout his career. What cannot be disputed is that the pack existed, that Oppenheimer carried it at Trinity, and that it showed changes consistent with radiation exposure. Whether those changes prove he walked into the crater that morning or merely confirm he stood at base camp as recorded depends on which technical interpretation you accept, and perhaps, more significantly, on whether you believe a man who had just birthed nuclear weapons would resist the compulsion to confront his creation face to face while it still burned. The Lucky Strike pack now resides in a climate-controlled vault at the Smithsonian Institution, transferred from Oak Ridge after Chun completed her analysis. It is not on public display. The filters have been sectioned from multiple studies, leaving only fragments of the original cigarettes, and the metallized paper has been sampled extensively for spectroscopic work. What remains is a ghost of the artifact, preserved because its destruction would itself be a kind of data loss, the erasure of a measurement that was never meant to be taken but that might tell us something essential about the moment when physics became history. Oppenheimer died in 1967 from throat cancer, a disease almost certainly caused by his lifelong smoking rather than radiation exposure. Though the two risk factors are multiplicative rather than additive, and disentangling their effects is impossible. He never spoke publicly about the cigarette pack. His personal papers contain no mention of it. The only evidence that he understood its significance comes from a letter written to Frank in 1960, 3 years before his death, in which he mentioned discarding a personal memento from the test during the FBI investigation. The phrasing is deliberately vague, but historians believe he was referring to the pack, which means he had kept it for 9 years after Trinity, before federal agents seized it, long enough to suggest it held meaning beyond its material composition. The question that remains, the ellipse at the center of this entire account, is whether Oppenheimer intended the pack to serve as a dosimeter from the beginning, or whether its evidential value was recognized only later. Perhaps, during those silent hours after the explosion when he confronted what he and his team had unleashed, did he carry it as an instrument or as a talisman? And does the distinction matter when the result was the same? A record of exposure that survived when official measurements failed or were suppressed. The cigarette pack measured what was not meant to be measured, preserved what was not meant to be preserved, and in doing so became a fossil of the atomic age's original sign. The moment when scientists stopped being observers and became participants in their own most dangerous experiment. If you have theories about what really happened during those missing 40 minutes, drop them in the comments below. Hit that like button if you think there are more artifacts like this waiting to be discovered in storage facilities across the country, and share this video with anyone who still believes the official story of Trinity tells the whole truth, because sometimes the most important measurements are the ones that were never supposed to exist at all.